Mr. Hissner here, and we're going to continue on with our CPCTC proofs, and this is going to be just a little bit more of a difficult proof, and let's just get into it. Here we have parallel, so right away I'm thinking alternating interior, especially by the looks of this figure, and then we have a midpoint. Okay, so what I'm going to do, I'm just going to write down my given information first. So these two things are given to us. Then we have D as the midpoint. And again, this is given. Okay, so we have parallel, we have a midpoint, and we need to prove that ED is congruent to CD. And again, that's probably going to be from CPCTC. So we have BC parallel to CEF, and we have D as the midpoint. Okay, so I'm thinking, okay, D is a midpoint. Well, let's first think of parallel. So if I choose a transversal, let's say this transversal, I know that alternating interior angles are congruent, and so angle B is going to be congruent to angle F. If D is the midpoint, that means it's going to chop this angle in half. And then we have a vertical angle right here. Vertical angles are when two intersecting lines kind of come about on either side of those intersecting lines. We have vertical angles. And so for me, I'm saying this is angle side angle. And I'm just going to go ahead and use that template to get started. So how about I use my my first one? So I'm going to use my angle. So I'm going to have, I'm just going to use angle B because there's only one angle B and it is congruent to angle F. And this is because they are alternating interior angles. Okay, so let me use the midpoint now. So I know that BD is going to be congruent to FD. And this is the definition of a midpoint. So I have a midpoint. That means two things are congruent. Okay, and now finally I'm going to do my vertical angle. So I have this one, I have to use 3 points because there's a bunch of angle Ds. So we have angle, how about BDC is congruent to angle BDC, angle FDE. And again, these are vertical angles. That's why this is the vertical angle theorem. The vertical angles is fine. And then, so we have that our triangle BDC is congruent to triangle FDE because we just did, and I did this on purpose, I did angle, side, angle. Angle, side, angle. And so these two segments, of course, are going to be congruent because congruent parts of congruent triangles, corresponding parts of congruent triangles are congruent. And so, yes, ED does correspond with CD. Yep. And that's it. And then we've done proof. So the idea here is that, you know, we're given some information, prove two triangles are congruent by whatever means necessary, and then wrap it up. Of course, then their corresponding parts will be congruent because of CPCTC. Thanks for watching.